Okay, welcome back to class, everybody. It's a pretty good time to get started. So just to begin, let's remind ourselves where we were before the weekend. So we spent one class hour talking about things like SciPy. So SciPy was the main scientific computing module in Python, and it allowed us to do things like create matrices. Typically, they're all of the same data type, and they're especially useful when you're doing scientific computation. Oftentimes, the matrices that you create are going to have floating point values because you're going to be doing some calculations with them. But another kind of matrix that we saw was really useful was Boolean matrices, right? So you could take a floating point matrix and write something like the matrix bigger than or equal to 2, and it would, Python would return to you a Boolean matrix that was just true or false for each one of the values where the original matrix was bigger than or equal to 2. And the nice thing about Boolean matrices was that you could use them to index other matrices. And in that way, you could do all kinds of amazing things without ever writing a for loop. And doing that is about 1,000 times faster, maybe even more than 1,000 times faster than writing a for loop to do the equivalent thing. So indexing in SciPy is tremendously useful. We also saw some of SciPy's modules. So some of the modules I highlighted were things like the linear algebra module, which has things like solving linear systems, finding eigenvalues or singular value decompositions. We did a small example with the optimization module, which has a ton of built-in optimization functions, and we used it to just optimize a scalar function, right? So it's really useful for that. And then towards the end of class, we looked a little bit at Matplotlib. So Matplotlib is Python's primary module for creating nice graphics. And it has a whole bunch of built-in functions to create some standard graphics like bar charts and line plots and so forth. But what's really nice about it is that you can essentially create anything you want. So if you spend a little bit of time reading the functions, you can create graphics that look exactly like you want them, exactly to represent your particular problem and the particular solutions in your problem. And towards the end of class, we just did one small example of that, where we tried to create a plot where we had some arrows that sort of like rotate from one side to the other. So just by show of hands, I'm curious, how many of you went home and completed that example? We sort of stopped without actually getting the arrows to work. How long did it take you? 15 minutes? Okay. So for me, like, it was basically three changes, like a sine to a cosine, like a minus pi or something like that. Like, it took about 30 seconds. So what I'm saying is it's worth it to spend some time to look at these things that we leave off in lecture. It's going to give you a little bit of practice to think about the problems that we think about. And we spent just the last 5 minutes of class talking about homework 1. So homework 1 is due on Thursday. Out of curiosity, how many people started it? How many people are done with it? Okay, great. So about half of you. So I just want to remind you all that, especially for homework assignments, I really encourage you to talk with each other, right? So spend some time trying to solve it by yourself, and regardless of whether you were successful or not, it might be useful to go and talk to your friend to see how they did it, because even if you were successful, maybe your friend did it in a different way that might be interesting to you, and you might learn a lot from it. So for those of you that are done, how many for loops did you use in your program? Yeah, 1. So in general, like, you should use almost no for loops in that program. I used 1. It's possible to perhaps even do it with no for loops. So maybe I can leave that as a challenge. So if any of you can write homework 1 without using any for loop, you can send me your code and maybe we'll go over it in class. Okay, so the plan for today is to spend some time talking about pandas. So pandas is the main lightweight, and when I say lightweight, what I mean by that is that 1, you don't have to install very much on your computer, and 2, it tends to work with sort of up to moderately sized data sets. It doesn't work with larger data sets. But it's the main lightweight method of working with data in Python. And we're going to go through some of the basic operations in pandas, how to import and export data, and so forth. Then we're going to spend some time talking about geographic data. So This is one of the things that's been becoming increasingly more important in both research and in applications. And so we're going to try to understand how basic geographic data sets are stored. And we're going to talk a little bit about plotting those geographic data sets. And I'll show you both some programs like Qgis, which is a free version of ArcGIS, where you can create some nice geographic plots. And we'll talk about how to create geographic plots in Python and maybe do some in class later today. And then if we get through all that, at the end we're going to talk about the Python Debugger and Profiler. So the Debugger and Profiler are two built-in tools to help you understand how your program is running. And that's especially important when it's not running correctly or it's running too slowly. So incredibly useful tools, especially when you start writing programs that are in the hundreds or thousands of lines of code that have a bug somewhere where you're not exactly sure where it is and why it is. Okay? So we'll take a look at those things maybe towards the end of class. So let's begin by looking at pandas. And just for a moment, I want to tell you something before we start with pandas. So we've been using the IPython notebook so far, and the primary reason I've been using it is because it provides you a record of all the things that we talk about in class. But as we start doing more complicated programs, I might switch to the IPython interpreter, okay, which means that you're not going to have this nice notebook format to sort of go back to. And both the notebook and the interpreter have some built-in extra functionality on top of standard Python. So this extra functionality is called the magic functions, okay, that's what they're called. And if you type %ls_magic here, and execute the cell, it's going to list for you all the available special magic functions. So one of the ones that you saw me write last time in class is I wrote something like %matplotlib space notebook. So that told Matplotlib to display all the pictures that we create inline inside of the notebook as opposed to pop up a new window, which is what it usually does. And there's various really useful things in here. One that I use especially often is run. Yeah, right there. So this one is incredibly useful. cpaste is incredibly useful. It's somewhere up there. And you can read help about what all of these do by just typing %magic. And it'll give you tons and tons of documentation about each one of those. So if you search over here, Matplotlib, so there's the Matplotlib magic function. And then over here is a bunch of documentation, like it lets you activate Matplotlib and interactive support, blah, 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 blah. Okay? So again, if you're interested in sort of learning a little bit more about the IPython interpreter, it can significantly increase your productivity to know about some of these magic functions. Okay? So let's just leave it at that and go back to talking about pandas. So the same way as SciPy and Matplotlib, we're going to start by importing pandas. Now let's take a look at the typical kind of data set that you might work with. So I've downloaded some data here. I'm just opening it up in a little spreadsheet application. Now let me try to increase the font. And if anybody knows how to increase the font, you can tell me what menu to go to here. Yeah. Say again? Fantastic. Okay, great. So let's take a look at what this data set looks like. So this data set basically has a bunch of last names and how popular they are in the population at large. So it has a bunch of columns. So the first is the surname. The second is the percentage of the population that has that surname. So Smith, there's about 1% of people that are Smith, and that's the most popular one. And then cumulative percent is just adds up all of the more popular surnames than that to see sort of where you are overall. That's like a CDF if this is a PDF, if you think about it that way. And then the rank just says like how popular it is, right? So Smith is the most popular, Johnson is the second most popular, Williams the third, and so forth, okay? So you might get all kinds of data sets like this. So data set typically looks like a table with a bunch of columns like this. And as we talked a little bit towards the beginning of class, when you get a data set, most commonly you're going to get it in either an Excel format, which looks like one of these spreadsheets, or a comma-separated value format like CSV, which if you print out kind of looks like this. So over there is my first row, that's all the column names, and after that is all the data. So you'll notice that unlike in the spreadsheet, things don't line up like very prettily when I print this to the screen, and that's because what's separating the columns here is the commas, right? And not spacing, which is what happens when I opened it up in the spreadsheet. And with CSVs, actually, it could be any character that's separating the columns, because maybe I want semicolons to separate them or tabs to separate them. That's another really common format. And so the first thing that we might want to do in Pandas is read a data set. So we're going to do that with this pandas.read csv. But before I execute that, let's take a look at what is there. So in particular, if you do pandas.read, in addition to .read CSV, which is what we're going to use in class primarily because CSVs are nice and easy to use, and you can email them back and forth really nicely without having special software, you can notice that there's an enormous amount of other data types that Pandas can automatically read in, right? So you have an Excel file, but you don't want to save it like a CSV before you start working with Pandas. Use Pandas Read Excel. So we're going to use this one. And then these are various other formats that you might run into as you're working with data. In particular, in companies, oftentimes people use things like SAS or Stata, and each of those proprietary software systems have their own special data format. But really, regardless of what data format it is, at the end it's really just storing a bunch of tables most of the time. And so what Pandas does is it lets you read in those tables into a nice Python data structure, okay? So then let's read what the options on Pandas Read CSV are. Okay, so Pandas Read CSV. So the first thing we're going to pass in is a file path. So what's the file that I want to read? Or it says a buffer. So for those of you that have done some working with files in Python, you can open up a file name by just doing the command open, and it returns like a file buffer, a file object, as opposed to just the name of the file. So I could pass either of those things into read CSV. So here's some other interesting thing, like the separator. And by default, it's a comma. So that has to do with what I said, that most of the time CSVs, the columns are separated by commas, but maybe you want them to be separated by something else. The header is also another interesting one, which is the top line, does it give you the column names, or is the top line data itself? And that's something that we also might want to play with. Some other things that I use sometimes are names, which allow you to name the column names if there is no header, and various, like tons and tons of options here that you can read about. And of course, just listing the options is not enough. You can go down here and read what all of these mean. So for example, whether I say separator or delimiter, like it's the same parameter, right? They just gave me two different names to refer to the same thing. Delimiter to use, if separator is none, we'll try to automatically determine this, you can use a regular expression. So how many of you are familiar with regular expressions? Have you done anything with regular expressions? So we'll do a little bit about it today. Regular expressions are tremendously useful when working with text data. What they allow you to do is take some text that's written and automatically extract from that sort of the pieces that are important to you. So imagine some automatically written log file that maybe has some timestamps, some words, and then some important piece of data after the words. You can extract the timestamp and the piece of data and sort of drop out the words with regular expressions. And we're going to do a little bit of that later today. But okay, so that's how you can find out what Read CSV does. And so so over here, we're going to read in the surname CSV. So when I do this, what Python does is it looks for the surnames.csv file in the current directory, right? I could put a much longer directory name over there, and then it'll look at that particular place. But if I don't specify a directory, it's going to look at the current directory. And this returns what's called a Pandas data frame object. So that's an object the same way that a SciPy array is. And it has some so this object df has a whole bunch of actions that you can do to it. And there's many more here than I typically use even. But one useful one is columns. So let's just print df.columns. And what that does is it's going to print the column names that Pandas read in from the CSV file. So this is useful for me to check, like, did it get the headers correctly, or was there some mess up somewhere in there? So it tells me that the columns it read in were surname, percent, cumulative percent, and rank. Okay. Okay. So now I have this. So let's print df. And so this is some automatic printing that Pandas provides. So these are the various columns. It nicely aligns everything. And then in addition to the actual columns and the data within the columns, when you read in a CSV file, Pandas creates what's called an index. Okay, so these numbers over here are the index to the data. So Smith is the row at index 0. Williams is the row at index 2, and so forth. Okay, so these were automatically created indices. But it's possible for you to tell Pandas to use one of the columns as an index, okay? So you could tell it, for example, use the rank column as the index. And then Pandas isn't going to automatically create one. It's going to use the one that you told it to use. And the way that you do that is with some more options on Read CSV, okay? And maybe we'll play a little bit with that a little bit later. Or, in fact, online, if you go onto the class webpage, there's some extra videos underneath our lectures. And one of those videos is on pandas and data frames, and it'll tell you about indexing and so forth. Okay, so one of the things that I might want to do now. Okay, so by the way, so here it is. We've printed it. And because there's so many rows, Pandas doesn't print everything. So it skipped here from row 29 to row 88,000 something, and then it prints the bottom of the data frame. So there's about almost 89,000 rows in this data frame. But one of the things that I might want to do is search for particular things within this data. So for example, I might be curious, how popular of a surname is Dimitrov? Okay, so let's see. Well, let me ask you a few questions before I run this. what do you think df.surname returns? That's right. So if I do df.surname, that's just the surname column, okay? But you notice it dropped the column name and everything, but it kept the index. So that's important because I might want to sort of refer back to the original data frame. So df.surname returns that column. And what do you think this expression returns? df.surname equals Dimitrov. It returns a column of Boolean values, right? So let's run that and see what happens. So here it is, df.surname Dimitrov. Okay, so again, a bunch of true falses, but again, it's going to keep the index and the appropriate true false value, okay? And so now, what do you think happens when I execute this? So df indexed with df equals Dimitrov, it's going to return exactly one row if it's there, right? It might be all falses. So it might return an empty data frame. But if it's there, it's going to return exactly one row. That's the row for Dimitrov and all the other columns along with that, okay? So this works very, very similar to indexing with Boolean arrays in SciPy. Almost exactly the same. It printed in a particularly nice way, maybe because we don't have very many rows in Pandas. So Dimitrov is about the 65,000th most popular name. There's 0% of the population, and this many names are more popular than Dimitrov. Okay. Okay, so we might be curious about a different name. So what about Dimitrov with two F's instead of a V? Let's see if that's somewhere in the data, and let's see how popular that is. Okay, so Dimitrov is slightly less popular at, slightly more popular at 57,000, the 57,000th most popular last name. Okay, so here's where we're going to talk a little bit about regular expressions. And a great way to find out about regular expressions is the Python documentation. So let's see. And maybe my network connection here doesn't work. So there's a module in Python called RE. RE stands for regular expressions. And you can use these on any sorts of strings. And regular expressions are basically strings that involve some special characters. And the special characters have particular interpretations. So let's just see some of these. So dot, for example, matches any character except the new line, okay? So if I want to say, find all strings that start with some character and then are followed by an A, what I would do is the regular expression that looks like this. Because what that says is any character followed by the character A.
Does it stand for like nothing?
It depends on the particular software that's implementing the regular expression. So sometimes you can say at least one, but I think in this particular case, it means I have to have a character there. And with questions like that, often I'll just run it a couple of times to see if it actually has the interpretation I think that it should have. Okay, so this caret character, shift 6, matches the start of a string. So if I want A's at the beginning of a string, what I would do is something like A, right? So that says, give me all strings that begin with a A. So end of a string, so star is one that I use a lot, so it causes the resulting regular expression to match 0 or more repetitions of the preceding regular expression, okay? So what would this do? And what's the difference between 1 and 2? Okay, so let's interpret 2. So I want a string. It has to start with a capital A, and then it has to be followed by any character, right? So, for example, capital A, lowercase n would match this, right? This, on the other hand, says you have to start with a capital A, and after that you can have whatever characters you want. You can have no character, you can have 1 character of whatever kind you want, or you can have like 15 characters of whatever kind you want, because the star says you can have 0 or more of whatever precedes. So in particular, here what's preceding is the dot, and so what we're saying is it has to start with a capital A, and you can have as many other characters as you want after that. And then a bunch of other useful ones. So question mark, 0 or 1 repetitions of the preceding regular expression, and various combinations of these. And you guys can read these on your own. But let me show you maybe just a couple of examples of how regular expressions work. So I'm going to import the regular expression module, and let's create some strings here. So just a list of strings: hello, Fred, A, Apple, Joe, and Microsoft. Okay, so a bunch of strings. And the regular expression module has a bunch of useful things in it. So one of them is match. So match just takes in a pattern and a string and just says, does this regular expression pattern match that particular string or not? Okay. We're going to look at some other ones like search and extract and so forth. But let's just start with match. Okay. So okay, so let's see what I'm attempting to do here, and you guys can maybe try to predict the output. So here's our list of strings. I'm iterating over all the strings, and I'm saying if this regular expression matches this particular word, then print out the word. So what things are going to get matched there? It should be just A and Apple, right? So hopefully when I print this, we just get A and Apple, right? So now help me match hello, Fred. Help me match hello, Fred, and just hello and Fred. So let's see what I wrote. So, by the way, very often with regular expressions, I do exactly what we're doing right now, which is just like a bunch of trial and error, right? So I write something that I think makes sense, test it a few times. I might have to go through a few debugging steps until I get it right, okay? But let's see what I wrote. What does it say? Take as many characters as you want, but then you have to have some character, then a E, followed by some character, and then how many ever characters you want after that, right? So should this match hello? So if we look at hello in this expression, the dot star is going to match nothing here, right? The H is going to get matched with this dot. The E is going to get matched with the E. The L is going to match with the second dot. And after that, the dot star is going to get matched with that LO, right? So similar with Fred, this first dot star is going to catch the F. That dot is going to catch the R, the E is going to catch the E, the second dot is going to catch the D, and the last dot star is going to catch nothing, right? And after that, why don't Apple and Joe match this? Because of this dot after the E, right? So if I run this, hopefully if we did our work right, it should just print hello and Fred, and it did, okay? And there might be various other ways to do it. But as you can see, this is incredibly powerful, right? It helps you go through lists of strings and pull out exactly the kinds of strings that are important to you through whatever sort of definition of important you might have. So here's another useful one. So let's just try this. So let's try the exact same expression that we have. Okay, so search is a nice way of basically pulling out data from inside of your regular expression, okay? So what these parentheses do is they basically capture the piece of the string that matches that particular part of the regular expression, right? So when we talked about this and Fred, we said that this is going to match the F, right? This dot is going to match the R. The E is going to match the E, that dot is going to match the D, and the last dot star is going to match nothing, right? And so I want to pull out those matches. And what I did here was with these parentheses just say pull out this match, that match, and that match. And so that returns what Python calls a regular expression search object. And from the search object, you can pull out the groups. So the groups are all the different matches for different pieces of the regular expression. So the first piece that got matched was the F, the second piece was the R, this piece was the D, and the last piece matched an empty string, okay? So for example, if I wrote some more stuff here, then what's groups, or what should it get printed out? Like all this stuff before the R should get printed out here. Right? So that's like the first part of the match. And it did, right? So just incredibly, incredibly useful. So think about sort of well-formatted sentences where you have a particular word followed by a bunch of words, and you want to pull out those bunch of words that come after the particular word that you want. What you do is you type out that word. The regular expression is going to match that. And then you do a dot star with some parentheses around it, and you can pull out all the stuff afterwards. Make sense? And we're going to use that with Pandas. So Pandas has built-in support for regular expressions, and that's what we're going to do next. So going back to our Pandas data frame, the first thing I want to do is I want to get rid of all surnames that are blank, just because they oftentimes are going to mess up my computation. I don't really care about those. So what this does is it just says, look at the surname column and look at any place of that column that just has blank values. And so this is going to return a true-false column the same way that we saw before. And what this does is it flips the true-false values. So this is a negation, the little tilde. So it's going to say, make data frame be just the part of data frame that doesn't have a null surname. Okay? So I hope that that line makes sense. And then let's read the next line and think about what that's going to return. So this says, look at the surname column. And when I say dot string, it says that column contains strings. And I'm going to do a string operation on all of them. So this is like a built-in for loop. The same way that we don't have to write for loops in SciPy, we don't have to write for loops in Pandas. What I want to do is iterate over all the values in that column. And for each of those values, I want to match with this regular expression. Okay? So what is this regular expression saying? Everything that starts with a D. So what we're saying here is just give me all the surnames that start with a D. Right? And so here they are. A bunch of surnames that start with Ds. Okay?
I'm sorry, I'm looking at the documentation and trying to follow along. What's the difference between dot star in this case and just star?
Okay, so great question. What would this do? So anybody else?
Even D matches.
It would look at either 0, 1, 2, or 3 Ds. So it's looking for just strings that are just repeated Ds.
Okay.
Because star says 0 or more repetitions of the previous regular expression.
Okay. So the dot says it can have anything after it.
The dot says any character, right? So this says, you know, empty string D, 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 right? Well, the other one says D, and then any character 0 or more times. And if we executed this, the reason that it matches this is because it's matching the empty string at the beginning.
Right.
Okay. So it's matching the empty string at the beginning of all those names. But so here we get all the ones that begin with D. Okay, so one of the things that you might want to do as you're looking through these data frames is you might want to pull out a particular one of these values. Like you want to pull out the cumulative percent of Dimitrov, okay? So the way to do that is, well, there are several ways, but one way to do that is this way. So that's going to actually return that particular number. So it's no longer a Pandas data frame. So what dot values does is it drops the data frame and returns you the floating point that's there. Versus if I did something like this, that's a Pandas data frame, right? So there's still a bunch of other data like the index of that row. There's the value there. There's also like the names of columns and so forth, right? But if I want just the data point, I can just do dot values. So dot values gives me all the values in that column, and dot value 0 pulls out that particular value. And there's a few other ways to do that. So let's see if I remember some of these. So this has to do with indexing data frames. So you can think of a data frame as a two-dimensional array where I have to give you a row value and a column value. So that's what we did here. So df surname equals Dimitrov, that's a big true-false array that indexes a row, right? And it might index several rows, but it indexes a row. And this indexes a column, right? Because it's the cumulative percent column. So IX is just a different way of doing that. And it looks very much like a SciPy kind of indexing. So first give me the row value. So here, surname equals Dimitrov, and then the column, cumulative percent. And let's see what this returns. And it's still not the actual number. It's still sort of wrapped in a pandas data frame kind of object. So you might still have to do value 0 to actually get the actual number. And this is often important if you're going to be using that number in some sort of follow-up computations, okay? Because you don't want to be sort of adding and subtracting to pandas data frame objects. You want to be adding and subtracting to the floating point value. Does that make sense? Okay. So one thing that's somewhat unpleasant is you'll notice that with surname, which was a column name, right? So surname was one of the column names. When I read in the data frame object, on the object automatically came in this attribute, so df.surname. So this was read in from the data file. But I can't do df.cumulative%. Why can't I do df.cumulative%? Because of the space. Like, so the space is really annoying. It sort of messes up my coding ability because Python doesn't allow spaces to be inside of identifiers, right? So surname doesn't have a space, so I could use it here, but cumulative percent does. And so I can't do df.cumulative space percent because Python's going to look for df.cumulative, right? And so this happens a lot. So it's quite often that I get data sets with spaces in the title, and I want to get rid of them, so I can be doing dot something as opposed to like indexing the particular column. So this useful sort of 3-line sequence, we can read through it. What it does is it just gets rid of all the columns, okay, or all the spaces in the column names. So let's read what it does. So it looks at data frame and it takes a look at that columns attribute. So remember the columns attribute, we printed it a few cells above. It just listed all the column names. Okay, so that's going to get stored in columns. Dot map, what it does is it takes each element of an array or a list and passes it through some function and returns the output of that function. So in particular, the function that we're going to pass it through here is a temporary function. Here we defined it with lambda x. So it takes in a parameter x and it just replaces space with underscore. Okay. Over here, so it does this if x is a string or a Unicode, and otherwise it returns x. Okay, so columns is going to get mapped this way. So let's just put some print statements in the middle here so we can see what's going on. So print columns, then print df.columns. So initially, columns has the space in it and cumulative percent. Over here, we mapped each of these through this replacement function, taking out the spaces and putting in underscores. So now we have cumulative underscore percent. And so df at the end has cumulative underscore percent. And which allows me to do things like now I can actually refer to that particular column, right? So if I print that, that's the cumulative percent column. So can be quite useful. Okay, so
I mean, for the output, why there is a U change?
so that just means that that's a Unicode string as opposed to a string. So it just has to do with telling you the way that that string gets stored in memory. So for those of you that are familiar, when computers started, people used to use ASCII to store characters. but ASCII wasn't enough to represent most of the letters that people wanted to represent, and so people switched to Unicode. So Unicode is just a different sort of storage format in memory for strings. Okay, so now we can do things like find out the cumulative percentage of Dimitrov the same way that we found a column. So what was the difference between this and what we had before? Right, here I had to pass in the string, while here I can actually just directly do .cumulative _%. Okay, so, say again? No, it's just sometimes more convenient when I write the code. So it's not so much in terms of execution speed, but maybe faster in terms of typing. Okay, so to have us sort of play around with Pandas some more, I created an extra data set. So let's take a look at this one. So this data set just has 2 columns in it. So you can't read it very well, but the first column is name, and the second column is cool. It has 2 entries. Dimitrov is true, and Dimitrov is false. Okay? So let's read in that data set. So here it is. Dimitrov is true, and Dimitrov is false. And so a common operation that you need to do in data sets is that you might have sort of 2 tables, right? So here I have my surnames table that has all the cumulative percentages, ranks, and so forth. And then I have my coolness table, which tells me that Dimitrov is cool. And so I want to sort of put those 2 together into one table. So so Pandas gives you some built-in functionality to do that. In particular, what do I want to do? I want to sort of go through all the surnames, and for each surname, add a new column. That's going to be like the coolness column, and look up in the coolness table to see what value that column should have. So that's what merge does. So I'm going to merge my original data frame with the second data frame, and on the left, I'm going to use the surname column, and on the right, I'm going to use the name column. Okay? So the reason I have to pass this in is because the things that I'm matching actually have different names in the different tables, right? So one of them was surname, and then the other one was just name. So let's see what that does. Okay, so it did something. So my merge, I had Dimitrov and Dimitrov. I got the cumulative percentage ranks. I also got the surname and the name because as far as Python is concerned, those are 2 different columns. They have different names. And I also got the cool column, but I lost all the other names, right? And that's because, so how many of you have had a database course before? Or have heard of the concept of like left join, right join, inner join, outer join, so forth, right? So depending on the kind of join that you're doing, you can specify what you want to do with all of those missing values, right? So there were a bunch of surnames that appeared in the surname data frame that didn't appear in the cool data frame. And so over here, it dropped those. But with the how parameter, I can specify the kind of join that I want to do. So here I want to do a left join, which means I want to keep all the rows of the original surname column, of the original surname table, okay? So let's take a look at that. So this keeps all the columns of the original surname data table. And then why would Smith get nan and a nan? Yeah, because it didn't have a match. So that's kind of a reasonable thing for Pandas to do. And there's probably, by looking at the documentation for the merge function, there's probably ways to specify defaults. And if you don't want to specify defaults, there's ways to, by using isNan, to go in and fill in the default that you want after the merge, okay? Okay, and we already know what columns merged has. Okay, so over here, what I'm trying to do is go in and fill in the default. So what we're doing is we're looking at the merge data set, and we're saying, look at all the rows that are null for cool, okay? And then in the cool column, make it false instead of nan, right? But if you execute this, it gives you an error. So in particular, it gives you a really nice error, and as I said before, this is a nice thing about Python. It says the value trying to be set on a copy of a slice of from a data frame. Try using .loc equals value instead. So this has to do with whether you're creating a copy or whether you're accessing the original data type. So in particular, over here, when I do some of this indexing, I'm not actually accessing the original data. Instead, I'm getting a copy of the data. So that's why equals false doesn't actually create the change that I wanted to change. But because the error is nice, you can go and read about this other function and try to use that to do the data changes that you want. So .loc is similar to .ix. So it's like indexing a two-dimensional array. So this is a row index and a column index, right? So this gives me all the rows that where cool is null. Look at the cool column and set that to false. And then we can take a look at what are the cool names. And the only one is Dimitrov because we set false to all the other ones. Okay. Okay, so Pandas does a tremendous amount more than what I've shown you. Okay, so I've shown you just the basics, but people use it all the time for many, many different kinds of data sets. So for example, one common data set that you might have is a time series, right? So there I have two columns. One is a timestamp, and the other is a data value. And you might want to do things like interpolate between your data values. You might want to have two time series and sort of line them up together. You might want to concatenate data frames, have one data frame and stick in the bottom data frame underneath it. You might have a huge data file that doesn't fit in memory, and you might want to read it into little chunks, right? So imagine a data file with 5 billion surnames that isn't going to fit into the memory of my machine. I might read it into little chunks of like 50,000 surnames at a time, as opposed to going through all 5 billion at a time. So Pandas gives you functionality to do all of these things, and it's massive, similar to the way that SciPy and Matplotlib are massive. And so typically when I program, what I do is I first think about what I want to do, and then I see if Pandas already has something implemented to allow me to do that, by looking online, by reading the Pandas documentation, and so forth. And we're going to do some of these other more complicated Pandas things for homework assignments later in the semester, okay? But let's switch topics a little bit and talk a little bit about plotting geographic data. So how many of you have heard about shapefiles before or have worked with shapefiles before? So maybe about 10% of you, not too many. But a shapefile was originally a proprietary data format created by Esri. That's the company that creates ArcGIS to store geographic data. So let me tell you a little bit about how shapefiles work. So a shapefile essentially has two pieces of information in it. So the first is a shape, and the second is some related data, okay? So a shape can be all kinds of things, like a point, a line, a polygon, or other things. And data associated with a shape could be anything. So this could be like a bunch of columns, like maybe like area, like population, maybe some other, like a fixed code, and so forth. So just to have an example in your mind, let's think of all the counties in Texas. So I might give you a shapefile that has all the counties in Texas. So each county would be specified as a shape, which is a polygon specified by all the lat-long coordinates of that polygon, okay? So, some county might look like this, and, we'd have all the points associated with that polygon, right? And in addition to that, to all these points, we might get a bunch of data on that county, like its area, its population, like maybe how much water it has, and so forth, okay? And so just to demonstrate some of this for you, so many of these shapefiles are just available online. So I'm just going to open up Qgis, which is the open source sort of geographic data set tool, kind of similar to ArcGIS. And I'm just going to import a particular shapefile. So just go to Layer, Add Layer, and Add Vector Layer. So I'm going to add this shapefile that I've downloaded. And it's a shapefile that has all the different counties in Texas. Okay? And on the side here, if you right-click on that particular layer, you can get various information on it. So in particular, if you look at properties, and if you look at fields, that's the data associated with each one of the shapes. So for example, these are each of the columns. So there's like a state FP, county, GeoID, name, and so forth. So each one of the shapes has all these 16 columns associated with it. Okay. So the other nice thing about QGIS is if you want to do like really complicated geographic data visualization, I recommend that you use this software tool to do it. So there are ways to have Python program QGIS and have it spit out a particular image on it. But let me just show you some interesting things that you might do. So if you just go to Properties, and you go to, let's say, Style, and let's go to Graduated, and here we can pick like the land area column, and let's go to, let's say, 8 classes, and let's apply that. And I picked a particular color map here that's a gradient from white to blue, and over here it tells you like the various area values and the associated color. And so if you go look at the map, now it's plotting the different counties based on their area and associated colors. And there's an enormous amount of flexibility there. Like you create your own classes, you can create your own colors, you can put labels on these counties. So if you go, for example, back to Properties and go to Labels, we could go show labels for this layer, and let's say let's label it with the name. And so now we have like a bunch of names associated with the various counties of Texas, and you can probably zoom in here, and it sort of like dynamically adjusts which labels are getting shown. And you can either print screen this, or there's very complicated, nice ways to print this into like a beautiful looking PDF that you can insert into whatever you want, okay? So there have been projects where the geographic visualization I've wanted to do has been sufficiently complicated that what I end up doing is navigating these menus to create the map that I want and then use that map. as I said, it is possible to do all of this via programming in Python, but it's actually just significantly more complicated than navigating the menus. And so if you want to do this, I suggest just navigating the menus, and you'll figure out how to do it. What I'll show you is a much sort of lighter weight, like a much simpler way of doing geographic plotting in Python that is still also very flexible, but doesn't scale as well. So one thing that's really nice about QGIS is you can stick in enormous geographic data sets here on the order of gigabytes, and it'll print it really beautifully, like in almost no time. While the other method that we're going to learn is slow. It's going to produce beautiful looking pictures, but it might take you, like if you have like a gigabyte's worth of geographic data with lots and lots of different polygons, it might take it like half an hour to draw that, okay? So let's take a look at the other method. So the other method is based around a part of Matplotlib. So if you just search Matplotlib base map, so that's the Python visualization toolkit that comes with Matplotlib that lets you look at geographic data. And there's a bunch of examples here. So let's maybe look at some of these. So you can do, so here's some code that you can cut and paste to produce a map that looks like that with Python. And we're going to do some of that in class. But to make your life easier, and also to make my life easier, over just like tens and tens of projects that I've had to do, all of which that have had to do with geographic visualization of one kind or another, what I've done is I've written my own class that sort of wraps a bunch of the Matplotlib functionality, okay? So I'm going to give you a copy of this that you can use for your own geographic plotting. So let's take a look at that class. So the class is called GeoPlotter. It comes in a file called geoplotter.py. And it's based on all these Matplotlib base map tools. So it imports Matplotlib base map, it imports SciPy, and it imports other Matplotlib tools. So the same way that SciPy and Matplotlib have built-in documentation, when you write code, you can build in documentation into your code. And that's what all these strings are doing. So for example, after I define the class GeoPlotter, over here is just a little bit of documentation to tell you or whoever might be using that what that class does. So it's a class for plotting geographic objects using Matplotlib. This is how you initialize one. It just creates a map. Keyword args are the arguments for a base map object. But it has various other functions like get axis, get figure, set axis size, set zoom, redraw, save the figure, draw map boundary, draw coastlines, etc., 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 etc. Okay, and you can read through all of these things to see what they do. But one of the ones that's going to be useful to us is this one called Read Shapefile. So that's the one where you pass in a particular shapefile, and it's going to read in all the geometries and all the attributes that come along with each of those geometries. And we're going to see that in just a moment. So let's see what this code does. So the first thing that it does is by writing import geoplotter, what Python does is it goes and looks for that geoplotter.py. It finds it in the current working directory, and then imports all of the tools that are in there. Okay. In particular, one of the things that it imports is the geoplotter class that's in there. So with this next line, the same way that we created a Mazda object a few classes ago, we're creating a geoplotter object. And then we do two things, which is just clear the map and then draw the world. So if you go, if you're curious what draw world does, you can go to geoplotter, and then let's look up draw world. So draw world is just a little helper function that just draws the map boundary, fills the continents, draws coastlines, draws countries, and draws the states. with various line widths in terms of the borders of each of those things. So let's see if we can run this.
So this is using the default base map that we're just writing in the county lines or whatever it's called shapefile.
Say again?
This is using the built-in base map, and then you're writing in the...
So the county lines I haven't read in yet.
Okay.
So nowhere in here have I referred to that shapefile. So base map with it comes with a bunch of data that has the country shapes and state shapes within there.
Just like zoom in on the part of the map that you're interested in.
Yeah, so we're going to see how to zoom into the part of the map that we're interested in just a moment. So, but first I need to import PyLab because I want to actually show this map after we execute it. And because I didn't execute one of those special sort of Matplotlib notebook things, instead of showing inline in the notebook, what it's giving me is this interactive map. Okay, so Draw World created all of this. It filled in the continents with a white shape, with a white color. It filled in the background with this blue, and then filled in all the countries and their states within each of the countries, as given by the Matplotlib base map dataset, okay? And as you say, right now I'm not zoomed into any particular part of that. So there's a couple of ways to zoom in. So one is you can zoom in interactively. So if you click in on the bottom here, there's a tool called Zoom to Rectangle, and we can do things like that with that tool. And there's another tool that allows you to just drag the map. That allows me to sort of zoom to a particular part of the map. So this is somewhat useful when you're playing around with data, but not very useful when you want to save a bunch of code and sort of recreate plots over and over again in a particular way that you want them to look, okay? So that's why in GeoPlotter, there's a set zoom function, okay, and you can go and look at its code, but it takes a lower left corner longitude, lower left corner latitude, upper right corner longitude, and upper right corner latitude to zoom into a particular part of the map that you want. So by specifying that box, it's going to like create maps that look exactly the same every single time you run the code without you having to mess around with things interactively. Okay? Okay, and we're going to use that. We're going to use set zoom shortly. So let's read the next part. So the next part, read a shapefile data. So this shapefile is from the U.S. Census Bureau, and then I zipped it in the current working directory. So read shapefile is another function that's on GeoPlotter. So let's read what that does. So read shapefile takes two parameters, the shapefile location and a name. And the documentation here says the location of the shapefile. For example, world borders, blah, 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 expects the corresponding shape, DBF, etc. files to be there. And the name is, the shapefile will be stored in self.m.name info and self.m.name info. Then you can use that to plot polygons, etc. on the map. Okay, so let me show you how to interpret that. So if you look at an actual shapefile, it's not just one file. So like the name shapefile is a little bit misleading. Okay, so if you download this shapefile, it will come in as a zip. And if you unzip that zip file, you end up getting these like 4 or 5 files. And the point here is that each of them store a different piece of the information. Like this file stores all the geometries, all the lat longs for all the counties, and this DBF file stores all of the table of values associated with each county. So let's read in the shapefile, and let's look at some of the data that comes along with that. I think it's going to give you a slightly better idea of what's going on. Okay, so here it is. We read that shapefile. And so I said take this shapefile and put it into what I'm going to call Texas County. And because I called it Texas County here, now I can refer to the geoplotter object. This is data associated with that object. And look at Texas County info. So this says, look at the information associated with the 0th polygon in that file. Okay, so let's see what these three shapes are. So this is the data associated with the 0th polygon. So the name 10 column of the DBF file associated with that polygon has the value Dallas. So this is basically Dallas County, right? So that's the county that all this data is associated with. These are some various numbers. So if you look at the Census Bureau website, it probably has an explanation for each one of these things, like water area, land area, so forth, some latitude and longitudes. This is like a longer name, like Dallas County instead of just Dallas. And there's some county FIPS codes and so forth. So there could be all kinds of, essentially like any piece of data that you could associate with this shape. But if you look at GeoPlotter, it also says that the shapefile will be stored in self.m.name and info and self.name.m.name info. So what I want to do also is I want to print g.m.texascounty0. Okay? And let's get rid of these other two. And the reason I did that is to show you the lat-long polygon data that actually describes Dallas County, okay? It's literally a whole bunch of points. So it starts here, right? So here's the first point, the second point, the third point, the fourth point, the fifth one, the sixth one, and so forth, right? So it's going across the border with little points sort of describing how to draw that polygon, okay? So suppose that you have never encountered geographic plotting, okay? And you don't know that software tools exist to do this. And all you know is what we talked about in class last time. And I asked you, given this information, to plot Dallas County using Matplotlib. What would you do? You could do that, yep. So you could sort of make a line that connects each one of these 2 points, and that's going to draw the border. But Matplotlib has patches in it. And in particular, it has like a polygon patch, okay? So you could just pass in all these points to a polygon patch and create one of those in Matplotlib, which has various attributes like edge color, fill color, and so forth. And you can make Dallas County look however you want it to look, okay? And that's, in fact, what we're going to do next. So anyway, it takes a lot of points to specify the border of a county. Okay, so let's draw the shapes. Okay, so draw shapes is again something on GeoPlotter. And let's see what we're passing in there. So we're saying, look at the Texas County file that I had read in. And over here, what we're doing is we're giving in a bunch of indices into that file. So which counties do I want to draw? And I'm saying SciPy A range, the length of Texas County info. So which counties am I saying we should draw? All of them, because I gave all the possible indices into the data, right? If I gave just the first 10, I would be only drawing the first 10 counties in the data set. Make sense? Okay, some other things that we're passing in here is the edge color, we want it black, the face color, we want white, and the line weights, we want to be 3. So let's run that, and let's show the figure. And I might have to rerun my previous draw world here, because we've run a bunch of things in between. So this draws the world that we saw before. And then this should draw so when I recreated the GeoPlotter object, I have to reread the county shapefile, and now I can actually draw those counties. So that's why I got this error that said that it has no Texas County info. Okay, and so now you can notice that Texas looks different than all the various other states. And if you zoom into Texas, you can see that now we've drawn the Texas counties, whereas the other states don't have counties. Okay. So so there's various other useful things, but one thing I'd like you to do, and maybe you could do it as an exercise, or we can do it at the beginning of class next time, is I want you to go and try to do this plotting. I'm going to post GeoPlotter online. I'm going to post the video from today online in this IPython notebook. I want you to draw Travis County in a different color, okay? So try drawing all the counties white the same way that we drew them in class, but then try just making Travis County be a different color from all the other counties. And try to automatically zoom to Texas, instead of interactively zooming the way that I did it. And the way that you're going to do it is by reading some more info here. So you can read the GeoPlotter documentation to figure out how to do that. Okay. And our next homework assignment, the one that's after this one, is going to be all about geographic plotting in pandas and so forth. So you guys are going to get a lot more practice doing that. So thanks a lot for listening, and I'll see you all on Thursday.